Okay, again, perpendicular lines creates a 90-degree angle, right? So that's why most of the time, perpendicular lines are connected with area of triangle questions. Maybe you will find the area of this triangle, ABC. There will be something like this, maybe in the future or maybe in your exams. Right, but for this, let's answer your homework. Let's go with number 10. Question is, calculate the perpendicular distance from the point -1, 4 to the line joining point A and B. So make a quick sketch, okay? So here's line AB, and then here is that point, -1, 4. All right. As you can see, this point here creates a perpendicular distance. Perpendicular distance is basically the length of this line. You can also use the distance formula for this one and finding this one. Okay, so this is the perpendicular line. Okay, intersecting line AB. Okay, so you have your 90-degree there, and then you have the coordinates of point. By the way, I name it point C. Okay, because this point has no name. So I put C and then I put point D as the intersection point between line AB and then let's say line CD. All right. So first, how do we find the perpendicular distance? How do we begin? When we talk about the distance formula, it's always the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So basically, class, to find the perpendicular distance, we need to have the coordinates of point C and point D, right? We need to have 2 points, right? However, our problem here is that we don't have the coordinates of the intersection point, or let's say point D. So what are we supposed to do now? Of course, we need to find the intersection point or point D here in order for us to find the distance or the perpendicular distance of this line, right? So first, how do we find the coordinates of point D? So there's no other way, right? If you have two lines that are intersecting, the only way that you can find that point is by what? By solving them simultaneously, right? So therefore, you need to find the equation of line AB and line CD, and then solve them simultaneously, and that's it. You find the coordinates of point D, right? So first, equation of AB. So first, we need to find the gradient of AB. That will give you 1/2, right? Okay, so you know the formula, right? So the gradient of AB is 1/2. So therefore, substituting everything in this formula, you can just choose A or B. It's up to you. Okay, so M is 1/2. Okay, I'll zoom it a bit. Okay, and then x sub 1 and y sub 1 is negative. Oh, sorry, 4n 1. I took point A. Yeah, I went for the smaller numbers. All right. So simplifying this, y is equal to 1/2 x minus 1. So this is your first equation. All right. And then for your second equation, let's say line CD, or the perpendicular line to AB. Now, I don't have to use the gradient formula because obviously I don't have point D here, right? I don't have coordinates of point D. So I'll just base the gradient of line CD from the gradient of line AB. It's because, again, they are perpendicular, so they are a negative reciprocal of each other. So negative reciprocal. So get the reciprocal, flip this. It becomes 2 over 1. And then negative, you multiply it by -1. So therefore, you will get -2 as the gradient of line CD. So applying it to this formula, okay, so of course, M is now -2. And then I've used point C, -1 and 4, as my x and y. So therefore, my second equation is this, -2x plus 2. All right, so there you have it. So those are your two equations. So now we can now solve for their intersection point, or basically point D. So, all right. So point D is okay, or will be solved by solving these two here simultaneously. Basically what I did here is use the substitution formula. Okay, so since these two here are equal to each other, just write them like this because they're both equal to y, right? Okay, and then just basically solve for x. So solving for x, you'll get 6 over 5 as your answer, right? You can use fraction, you can use decimal, it's up to you. All right, but I suggest fractions. Okay. Okay. So and then so that's the value of x. For the value of y, just choose one of either of this. So I chose the first. Sorry, yeah, the second one, and then I got -2 over 5. So here are the coordinates of point B. Okay. 6, 5, and then -2 over 5. And then, so basically, I can now find the perpendicular distance, okay, from point C to this line AB. So I'll just get the distance of line CD. So finding the distance of line CD, okay, so use this point and then the new point, which is, let's say, line D, point D. Then substitute everything in this formula, and then you'll eventually get 11 root 5 over 5. Okay, that's for number 10. Okay, now any question, class, for number 10? Okay, so basically that's it. Okay, all right. Now in one question we applied a lot of things, right? Have you noticed that? So we applied gradient, we have applied the equation of the line, we applied, of course, perpendicular gradients or perpendicular lines, and then we also applied, again, simultaneous equations, and then we apply the distance formula. So in your test, you'll have one question like this. One question, but you know, there are multiple things that you need to find. Okay, so at least try to you know, write the formula. Okay, in your notebooks, in your notes. All right, so that's it for your homework. Okay, so now let's jump to the second to the last topic on chapter 7, which is about perpendicular bisector. Now, back in Sec 1, do you still remember Sec 1? Okay. You were asked your teachers to draw lines, right? Using um, compass, protractors, pencil, rulers, everything, right? Now, one of the things that you drew there was called perpendicular bisector. I think what that was the first thing that you learned to draw, right? Wherein you have a straight line, then how do you make this line equal on both sides, right? Because by definition, the perpendicular bisector is a line that bisects this line here exactly into two equal parts. When you see the word bisector, means exactly in half, right? That's why we also have angle bisector, right? You have an angle, it divides the angle into two equal angles, right? So when you see perpendicular bisector, this one is basically in the middle of a line. So of course, if you have line AB, if this is your perpendicular bisector, that means that the distance between the bisector to point A is equal to the perpendicular bisector to point B. So basically, if this is 5 centimeters, this is also 5 centimeters. Now, for this last part, or maybe second to the last part, what our objective here, class, is to find the equation of this line here, the equation of the perpendicular bisector. Okay, so how are we going to do that? Okay, now again, definition, it's at the middle, in the middle. So what do you think should we find first? If we're looking for where is middle, what are we supposed to do now? Okay, if we're looking for the equation of the perpendicular bisector. Okay, I have here example 20 to explain that or to apply concept. Okay, all right. Now example 20 here is asking us, okay, to find the equation of the perpendicular bisector of AB. Now, actually, this is a guided question because here it's already telling you that you need to find the midpoint AB. It's because if you have a line and it's the perpendicular bisector, that means that the perpendicular bisector is exactly in the middle of AB. So that's your point. That's the point that you need for the equation of the line. All right. So first, you need to find the midpoint of AB. So yeah, so finding the midpoint of AB. Do you still remember how to find the midpoint between 2 points? All right. So just add the x and the y values, divide both by 2. So this is your x. This is your y. So therefore, the midpoint of AB is 3 1/2. Okay, 3 1/2. So this is the coordinates of the midpoint of AB. Any question, class, on letter A? All right, none. Okay, again, you add your x. That's why this is 1 plus 5. Add your y. That's why this is 2 minus 1. And then divide by 2. So here's your answer. So done. Okay, now let's go to letter B. Now, letter B is where we answer the actual question. Okay, so before we go to the equation of the line, we should know, class, that, okay, so let me draw this. So for example, this is line AB, right? Okay, and then let's say this is the perpendicular bisector of line AB, the blue line, right? Okay, let me just adjust this. Okay, so let's say that's the perpendicular bisector. Okay, now we should make this to equal, right? Okay, now the gradient of, sorry, the midpoint of AB is this, right? This one. So that is 3 1/2, right? This one. So you have your point. Okay, but in order for you to find the equation of the line, you need a gradient, right? You need the gradient. So first, find the gradient of AB, and then you'll get -3/4. Take note, class, that that is the gradient of AB, not the perpendicular bisector. Okay, this is where some students get confused. This gradient here is for line AB, not for the perpendicular bisector. Take note, okay? So basically, the gradient of line AB is -3/4. Now, if you're looking for the equation of the perpendicular bisector, basically you need to get the gradient of the perpendicular bisector. Now, since we don't have any points, okay, we don't have any known points besides the midpoint, for the perpendicular bisector, we cannot find the gradient, okay, because we only have 1 point. So therefore, we're just going the gradient of the perpendicular bisector by the gradient of line AB. Because again, they're perpendicular to each other. That means that the gradient of the perpendicular bisector is negative reciprocal of the gradient of AB. So if this is -3/4, you flip this, it becomes 4/3, right? And then if you multiply this by -1, it will become positive 4/3. So that's how I get 4/3. So that is the gradient of perpendicular bisector. Okay, so from there, I have now my gradient. I now have a point. So we can now basically solve or get the equation of the line. All right. Okay, so I forgot the m here. All right. So everything's here. So just substitute this here, and this is x and y. Okay, and then there you go. When you simplify this, you'll get y equals 4/3 x minus 7/2, or you can also write it this way. It's up to you, but both are accepted as your final. Okay. So again, you're given 2 points. Okay, wait, yeah, I'll just. Okay, wait, guys. I'll just. All right, there you go. Okay. So again, you're given 2 points, point A and B. So you need to find the equation of the perpendicular bisector. Now, find the midpoint first of AB. So 1 plus 7 divided by 2, and then for your y value, 8 minus 4 divided by 2. So therefore, the coordinates of your midpoint is 4, 2. Now, next is you need to have a gradient, right? Now, first, find the gradient of AB. So doing so, you have negative 4 minus 8, and then 7 minus 1. Okay, so you will end up with negative 2 as your gradient for AB. Now, take note that this is not yet, or this is not the gradient of the perpendicular bisector. The gradient of the perpendicular bisector is always the negative reciprocal of this answer. So therefore, the gradient of the perpendicular bisector is 1/2. Again, negative reciprocal. You flip this, it becomes 1 over negative 2, and then you multiply it by a negative 1. That's why you have a positive 1/2 here. Okay? So basically, these are the two things that you need in order for you to find the equation. So therefore, substituting this for x and y, and then this is your gradient. Simplifying this, you'll get y is equal to 1/2 x. Okay, you don't have to put plus 0 there. So this is your final answer for 1B. Any question, class? Okay, so no questions, yeah? All right. So, okay, so let's have another example. Okay, last one for this topic. Okay. Okay, this one, okay, example 21. So if you have 2 points which have coordinates A, negative 2, 3, and B, 4, and 15, we need to find the equation of the perpendicular bisector of AB. That's the first question here. Hence or otherwise, calculate the coordinates of the point P of the line 3y equals x plus 1 if P is equidistant from A and B. Now, there are two questions here again, class. On the first question, you just basically need to find the equation of the perpendicular bisector of AB. So that's what we're going to do first, right? So again, if you need to find the perpendicular bisector of AB or the equation of it, you need to find the midpoint of A and B, right? So negative 2 plus 4 divided by 2, and then 3 plus 15 divided by 2. And then your midpoint is at 1, 9. Okay, right. Now, next is we need the gradient of the perpendicular bisector. So first, find the gradient of AB, which is 2. Now, if you need to find the gradient of the perpendicular bisector, you need to get the negative reciprocal of 2, which is negative 1/2, right? So you have this 2, you have the point, midpoint, and then the gradient of the perpendicular bisector. So you can just substitute them here in this formula. So doing so, simplifying everything, you'll get y equals negative 1/2 x plus 19 over 2. Or you can write the answer this way. It's okay. They're both correct. All right. So that's it. That's your answer for the first question. Now, on the second question, okay, so it's better if you see a drawing here. Now, it says here that we need to calculate the coordinates of point P on the line 3y equals x plus 1. What does it mean? Now, this is your line AB from the first part of this question, right? And this is the perpendicular bisector of line AB. So basically, the first equation that you took, the y equals 1/2 x plus 19 over 2 is for this line, okay, for this one. All right. Now, it says here that, okay, that there's another line, okay, that intersected your perpendicular bisector. Now, this line is 3y equals x plus 1. Now, and then when they intersected, it created this point, which is point P. And it also says that point P is equidistant from A and B. That means basically if you form this as a triangle, you'll have here an isosceles triangle. That's what it means. All right, equidistant from point A and B. Okay. All right, but actually the word equidistance from A and B actually don't matter if you're not solving for anything related to that. Okay. The only thing that you need to know here, class, is you need to find the equation. Oh, sorry, the coordinates of point P. By having these two lines over here. Okay. So basically, you need to solve this simultaneously, right? So this is from the first part of the question. This is the equation of the perpendicular bisector. And then this is the equation of this given line. Okay. And then again, they intersected at point P. So you need to find the coordinates of point P. So we solve this simultaneously, right? So what I did here is because they're both written this way, I've changed my first equation into in terms of y. So it becomes x equals negative 2y plus 19, right? And then I'm going to substitute this to the second equation. So therefore, it becomes 3y equals, instead of x, it becomes negative 2y plus 19 and then plus 1, right? And then solving for y is equal to 4. Okay. And then solving for x, I'll just go with this. Okay. So x minus 2y. So y is 4. Therefore, your x is equal to 11. So that's it. So your final answer is P. Point P is at 11, 4. So this is the coordinates of the point P. Okay. So are there any questions, class? For example, 21. All right. Okay. Now, I'm going to give you homework about this, but let me just go to the last part because you already known that since before, since sec 2. Okay. Now, this is the last part of this chapter. Intersection of a straight line and a curve. Basically, if you have a straight line and a quadratic curve, they will always intersect, or most of the time intersect at 2 points, right? Okay. Now, what you're after here is for you to find the coordinates of those 2 points. We already had this before, class. So I'm just going through this one, okay? So we can only solve this by solving them simultaneously or simultaneous equations again. So for example, I'll just have one example on this one. Okay, the line y equals 2x minus 2 intersects the curve at y equals x squared minus 2x plus 1 at 2 points. Find the coordinates of these points. Okay, so you have your 2 points, you have a line and a curve. So you need to find the 2 points or the two intersection points of these two graphs. So solve them simultaneously, right? So just make them equal to each other, okay, like this. And then eventually ending up with quadratic equations, right? So how do you answer this? How do you find the values of x? So you can just use factorization on this one. So you'll get x minus 3 times x minus 1, right? Factors of positive 3, sum of negative 4. Okay, negative 3 times negative 1 is positive 3. When you add this two, you'll get negative 4. That equals 0. And then equate each term by 0. So your first x is 3, and then your second x is 1. So you have your x values. And then to find for the y values, just choose either of this. Okay, of course, I'll just choose the linear because it's way simpler to solve. So substituting the value of x, when x is 3, y is equal to 4. So that's my first point. And then when x is equal to 1, y is equal to 0. That is my second point. And then that's it. Okay, so that's how you solve the intersection of a line and a curve. All right, any question, class?